So today we are going to solve this question which goes by the name contrast value. So let's read the question first. For an array of integers, let's call the value mod of a1 minus a2 plus mod of a2 minus a3 and so on, the contrast of a. Now, let's look at what this means is, let's say you have given values like 3, 5, 8, 4. So the contrast will be mod of 3 minus 5 plus mod of 5 minus 8 plus mod of 8 minus 4. This will be the contrast of this array. Now, let's read the question further. And here you can note that the contrast of any array of size 1 is equal to 0. It means when the array has size equals to 1, the contrast will be 0. Now, you are given this array. Our task is to build an array B in such a way that the following conditions are met. B is not empty. It means at least one element should be present in the array B. Now, B is a subsequence of A. It means the elements in array B should exist as a subsequence in array A. Now, what you have to find is the minimum possible size of the array B. So let's take this example 1 3 3 3 7. Let's take this example 1 3 3 3 7. What will be the contrast value? 1 minus 3 mod plus 3 minus 3 mod plus again 3 minus 3 mod plus 3 minus 7. Here you can notice that if the values are equal, it does not matter because it does not add anything into the contrast value. It means it is 0, it is 0. So it does not anything into the contrast value. So maybe we can remove the repeating values. It means in these three numbers, we can only have one number and remove these two. We will also get one more reason why we are removing this. Now, one more thing you can see in this question is it is simply the contrast value. Let's say if we remove this, the contrast here we will get 2 and here we will get 4. So the contrast value is equals to 6. These values are 0. So we are removing it. Now, if we look at this, if we simply take these two, we have to take minimum numbers. So if we take only these two, 1 and 7, in this the contrast value will be 1 minus 7, which is also equals to 6, and both are same. Now let's take one more example. Let's say we have been given 1, 4, 9, 9, 7, 5, and then again, let's say 8 and 9. This has been given. Now, the contrast value will be 1 minus 4, 1 minus 4 mod plus 4 minus 9 mod, 4 minus 9 mod plus 9 minus 9 mod plus 9 minus 7 mod, 9 minus 7 mod plus 7 minus 5 mod, and so on. Or we can write it 5 minus 8 mod, 5 minus 8 mod plus 8 minus 9 mod, 8 minus 9 mod. Now, in this question, you cannot write the contrast value of all these will be equal to 1 minus 9 mod. This will not be true because you can see here, we are going from 1 to 4, 4 to 9, 9 to 9, and 9 to 7. Here we are decreasing. So we cannot say that 1 minus 7 will be equal to contrast value of all, because let's say numbers are increasing, then decreasing, then increasing. Here, let's say this is 1, this is 4, this is 3, and this is 7. So the contrast value will be equal to 1 minus 4 plus 4 minus 3 plus 3 minus 7. Here it will be 3, 1, and 4. If we take 1 and 7, it will come as 6, which will not be equal to this number. So we cannot say that the contrast value will be equal. Now let's take only this part. See this only this part. Let's say here number is 2 and here number is 3. In this, we can say that the contrast value of this, and this will be 1, 1, and 1. And this will be 3. So these values will be equal to 3. So what we can decide from this? That if number is like, sorry, if number is like this, we can take this value, and here, from here to here, contrast values will be same. We can take this value, we can take this value, and we can take this value. So what should code hour look like? What should code hour look like? We can say that, let's say if we are changing our direction here to here, here to here, here to here. If we are changing our direction, then we can say that we can take that value. Initially, we will take this value. We will start checking if number is here. What we can do? Both the numbers are less than this number, or both the numbers are greater than this value. If this condition is met, we can say that we can choose this value. Now we will look at why we were removing the equal numbers. We will look at this. Let's say the number is like here, then decreasing here and here. Let's select this. Now, in this one, we cannot check. In this one, we cannot check if the number are both less than this, or if the numbers are both greater than this. We cannot check this. That's why we were just keeping the one value and removing all the other equal value. Let's say if this is 2, then we were removing all other number equal to 2. Then we will get something like this, something like this. Then we can apply our algorithm. Let's say if all numbers are equal, let's say it's like this: 2, 2, 2, 2, and 2. Let's say like this. Then what we can do is the contrast value of this will be 0. And we have seen that in the question, we have seen that the contrast value of size 1 is equals to 0. So we can take only one value. Let's say we take just 2. The contrast value of this will be 0. Now, it's like if just like this, if you can say the array is just like this, let's say 1, 5, 9, just like this, we can take contrast value just 2, this and this. All right. Now let's go to the code and look, and we will look at it, how we are going to solve this question. So here you can say I'm taking the value of n. Here I'm taking the input array, and I am taking count as 1 because the first number we are, you can say, I am taking the first number. If you look at this example, I am including this first number. Now, what we will do is, here we are taking all the different values. Here we will remove the common values. How we will remove it? Let's say we are first pushing the first element. We are taking the array a different array. We are pushing the first element. Now we will run the loop from 1 to n. You can say less than n. If here the array was ARR, here the array is A, which is different than both of this. You can say you can get confused between these two, but you should not. Let's say if array of I is not equals to array a dot back, it means if the ith element of array is not equals to back of the eighth element, then we should push this. We should push this into the array A. Let's say example you can take 1, 3, 3, 4. A will be 1. If this is equals to this, no, this is not equal, then we can push this. Is this equal to this? Yes, we will not push this. Is this equal to this? No, then we will push this. So in this way, we will get different elements. Now, here we will iterate from 1 to a of size minus 1. Less than, you can say less than to a of size minus 2. It is running from 1 to a of size minus 2. And we are checking if I minus 1th element is less than ai and I plus 1th element is less than ai, or either we can either we will get this point or this point, or I minus 1 is greater than ai, I plus 1 is greater than ai. If this is the case, we will increase the count number. What it means is we will include this one. Now see this, if the count is 1, let's say if the count is 1, it means either this can be either this will be there, so we will get, let's say if this is 2, or like this. Here numbers are like this. In this, only 2 will be included because we were pushing this element at first, and no other element will be pushed into the array A. Similarly, in this one, no other element will be pushed into the array. But there is a problem. In this, we will include only one. Let's say if all were twos, we will just give one number to answer as 1, count equals to 1, and this will be okay. But in this, you have to give 2. This number, and then let's say if this is 9, then you have to give count equals to 2. So for this, we are checking if count is equals to 1, and if the back element of array A is equal to array of 0. It means if it means all the elements were equal, then we will just give 1 as answer. Otherwise, we will give count plus 1 as answer. So I hope you would have understood this question. Thank you.